Okay, now let us discuss question number 11, 12, 13, 14 and 15 from the practice sheet. They are based on the concept of segment of a circle. We have discussed the concept, now it is time to discuss question number 11, which is based on the same concept. And you can see question number 11 says find the area of the segment AYB as shown in figure if the radius of the circle is 21 centimeters and the angle AOB is equals to 120 centimeters. Okay, so question number 11 says in this figure, this is a figure where this is AB is a chord and OA and OB are the radius. Radius is 21 centimeters and the angle, this angle is 120 degrees. Okay, this angle is 120 degrees. Now, I need to calculate the area of this segment. This is Y. I need to calculate the area of this segment. So, what is the formula to calculate area of segment? Area of segment is equals to area of sector minus area of triangle. We know this formula. Now, area of sector is theta into pi r square upon 360 degrees minus area of triangle is half r square sine of angle theta. Okay. Now, what is theta? Theta is equals to 120 degrees. So, here I will have 120 into pi into 21 square upon this is 360. Now, solving this, value and then minus half of 21 square into sine of 120 degrees. Okay, this is sine of 120 degrees. Now, further solving this will give you what we can see. This is cancelled and this is 3 times. So, you will have pi into 21 square upon 3 minus pi into 21 square upon 3 minus 21 square upon 2 into sine of angle 120 degrees. Now, how to calculate the value of sine of angle 120 degrees? For that, remember, I will give you an identity. Identity is a trigonometric identity. It says that sine of 90 plus theta is equals to cos theta. Okay. This is a trigonometric identity that you need to remember. It says sine of 90 plus theta is basically cos theta. So, what I have is sine of 120 degree. Now, how can I write sine of 120 in this values, in this notation? I can write it as sine of 90 plus 30. Okay, 90 plus 30. So, sine of 90 as it is plus 30 is theta. And this is equals to cos theta. Now, here theta is equal to 30 degree. So, I will say this is equals to cos 30 degrees. Okay. Now, what is the value of cos 30 degree? Cos 30 degree is equals to, so sine of 120 degree is equals to cos 30 degree and we know the value of cos 30 is root 3 upon 2. So, sine of angle 120 is equals to root 3 divided by 2. Now, we have sine of 120, we have values of this area of sector. So, now I can substitute this value, I will get pi. Now, I can take 21 as common, 21 square as common to the bracket. I will be left with pi by 2 minus this will be 1 upon 2 into root 3 upon 2 and this will give you 21 square to the bracket pi by 2 minus root 3 upon 4. So, you can solve this and determine the area of segment. This is in unit square, or we can see The radius is given in centimeters, so area will be centimeter square. This is the required area of segment that we need to calculate. Okay, so this completes question number 11. Okay, so now let us discuss question number 12. We have completed question number 11. It's a very simple question. Only the complexity arises here when you see this kind of angle as 120 degree. So you might feel we haven't studied about angle 120. We have studied up to only angle 90 degrees. Then how to calculate the value. So believe me, you will not get very much difficult question. Only the task that you need to remember is angle 120. Further you will not have any other values. Okay, and remember this identity. From this identity I can even calculate the values of sine of angle 150 degree or sine of angle 225 degree and all these values. Okay, so remember this value, this identity. This is an important identity. Now next question, question number 12 says a chord of a circle of radius 10 centimeters subtends a right angle at the center. Okay, so there is a chord in a circle which subtend a right angle at the center. Find the area of the corresponding minor segment and second the major sector. Okay, so question number 12 says there is a circle and there is a chord which subtends a right angle at the center. Let us say O is the center and AB is the chord. AB chord subtends an angle of 90 degree at the center. Okay, now I need to calculate the area of minor segment. What is the minor segment? This is known as the minor segment. And what is the major segment? Major segment will be known as this one. This complete segment, the part which is left after removing the minor segment will be known as the major segment. For example, एक बड़ा सा पापड़ है, उसमें से मैंने इतना टुकड़ा तोड़ लिया, this much part, ऐसा करके हटा दिया, तो जो बचा हुआ पापड़ है, that will be your major segment. Okay, so I need to calculate area of this minor segment and I need to calculate the area of major sector. First, let us determine the area of this minor segment. The radius is given as 10 centimeters. Okay, so radius is 10 centimeters. I will find the area of minor segment. The area of minor segment will be equals to area of minor sector minus area of triangle. Okay, area of sector minus area of triangle. So area of minor sector is theta is 90 degree. So 90 degree into pi into r is 10 square upon 360 and minus half into radius is again 10 square into sine of angle 90 degree because theta is equal to 90 degree. So sine of 90 degrees. So solving this will be 4 times and you will going to have 10 square as common to the bracket pi by 4 minus this sine theta will be 1. So minus 1 upon 2 centimeter square. So this will be the area of minor segment. You can simplify this value, okay, or you can leave it here also. It do not matter if you solve this 22 upon 7 as pi and solve all and complete solution. It may not be possible every time because if you are in exam and you are left with a very little time, what you can do is you can leave this question here and move to the next question. It's because the calculation part further will deduct only half marks for you. Okay, the calculation part after this will carry only half marks. So you can take a chance of half marks here and calculate or solve some other question which is a bit of more marks compared to this half marks. Okay, so this is the area of minor segment. Then area of major sector. Now what will be the area of major sector? I can solve it in two ways. what I can do is I can calculate the area of circle and subtract the area of this minor sector to get the area of major sector, or I can directly determine the value, the area of major sector. How? The angle subtended by this major sector, let us mark this major sector first. What I am saying is the angle subtended by this major sector, just focus on this major sector. This is my major sector. Now, what is the angle subtended by this major sector at the center? I can see this is the angle that it subtend, because minor sector subtend this much angle. So, major sectors will subtend this angle. Now, total angle is 360 degree. If I subtract this angle, that is 90 degree, this will give you 270 degree. So, 270 degree is the angle subtended by major sector. Okay, angle subtended by major sector. So, area of major sector will be equals to theta, that is 270 into pi into r square, r is 10 square upon 360 degree. So, this 0 and 0 will get cancelled. This is 3, you can solve this 9 3s and 9 4s. So, the area will be, this is 4, this is 100. So, 100 upon 4 will give you 25, 25 3s is 75, 75 pi centimeter square. Okay. So, this will be the area of major sector. In this way you can calculate the area of major sector. So, this is the solution for question number 12 also. Okay, first you note this, then we will solve further. Okay, now let us solve question number 13. Question number 13 says, in a circle of radius 21 centimeters, an arc subtends an angle of 60 degree at the center. Okay, so let us draw the diagram for question number 13. It says in a circle of radius 21 centimeters. So there is a circle and the radius of this circle is 21 centimeters. An arc subtends an angle of 60 degree at the center. So if this is O, I can assume OA as the radius and OB also as the radius, and I can see AB can be considered as an arc. This arc subtends an angle of 60 degree at the center. Okay. Find the length of the arc. You need to determine the length of the arc. Now, what will be the length of this arc? We have determined, we have understood, we have derived the formula for length of the arc. Length of arc AB will be equals to, it will be equals to theta into 2 pi r upon 360 degrees. So, yes, and this is 60 degree into 2 into pi into radius is 21 upon 360. So, this 0, this is 6, then this is 3, this is cancelled. So, I will get 21, so this is 7. So, I will get 7 pi, okay, 7 pi centimeters. This is the length of arc AB. It is very simple, just the application of formula theta into 2 pi r upon 360. The perimeter of arc will be theta into 2 pi r upon 360 plus this radius, perimeter of the sector. Here I am just talking about the length of arc AB. Okay. Then find the area of the sector formed by arc. What will be the area of sector? Area of sector will be equals to theta into pi r square upon 360. So, you can further put it as 60 into pi into 21 square upon 360 and just solve this. Okay. So, you can solve this, this is a basic calculation, and from this you can calculate the area of sector. Then third thing is area of the segment formed by the corresponding chord. Now, which is the chord? The chord is The one which is formed by joining the end points of this arc. So I need to determine the area of this segment. What is the area of segment? Area of segment is equals to area of sector. I can directly write the formula, theta into pi r square upon 360 minus half into area of triangle, that is half into r square into sine of angle theta. So theta is what? What is theta? Theta is 60 degrees. So 60 degree into pi r square upon 360 minus half into r square into, now theta is 60 degrees. So sine 60 degree is what? Sine 60 degree is root 3 by 2. Okay, this is root 3 by 2. So further solving this is 6. You will get, if I take r square as common, in bracket it will be pi by 6 minus, this will give you root 3 by 4 centimeter square. So this will represent the area of sector or area of segment formed by this arc. Okay, so this is the area of segment. So this completes question number 13. Again a very easy question. Now let us solve 14th one. Question number 14 says, a chord of a circle of radius 15 centimeters subtends an angle of 60 degree at the center. Find the areas of corresponding major and minor segments. Okay, so question number 14. There is a chord of a circle of radius 15 centimeter. The circle is of radius 15 centimeters and it subtends an angle of 60 degree at the center. This is 15 centimeters, this is O, this is A, this is B, and it subtends an angle of 60 degree at the center. Okay, find the areas of corresponding major and minor segments. So what are the segments? This is the minor segment and this complete is the major segment, this one. This is the major segment and this part is a minor segment. Okay, so area of this minor segment, area of minor segment is equals to area of sector. What is sector? Sector is theta upon 360 into pi r square. So this is theta is 60 degree into pi r square, r is 15 square upon 360 minus area of triangle. Triangle is half r square, that is 15 square into sine of angle 60 degrees. Okay, this will be into sine of angle 60 degrees. So area is equals to, now I can again solve this, 60, this is 6, so 15 square can be taken as common, to the bracket it will be pi by 6, okay, minus root 3 by 4, and you can solve this part. Okay, I am not solving this part. This is the area of minor segment. Now how to calculate the area of major segment? Area of major segment is equals to area of circle minus area of minor segment. Okay, it is the area of circle minus area of minor segment. Now what is the area of circle? Area of circle is pi into 15 square minus, it will be 15 square to the bracket pi by 6 minus root 3 by 4. Okay, and you can solve this to calculate the area of major segment. What I have done, I have removed this much part from the circle, so I will be left with the major segment, this part. Okay, so from this I can determine the area of major segment as well. So this is the solution for question number 14. Now let us solve question number 15. Question number 15 says a chord of a circle of radius 12 centimeters subtends an angle of 120 degree at the center. Find the area of corresponding segment of the circle. Again the same kind of question. In this chapter you will find mostly the questions which are of same approach. They just require you to substitute two formulas only, that is the major segments, sectors, the concept of sectors and the concept of segments. This chapter contains only two different concepts, and in each and every time you just have to apply these two approaches, these two concepts. Okay, so 15th one, there is a circle, and in this circle this is, let us say, center O, this is A and B, and this particular chord subtends an angle of 120 degrees at the center. This is the chord AB. Okay, this is the chord AB. I need to calculate the area of segment. This segment, what will be the area? Area will be equals to area of segment will be equals to area of sector minus area of triangle. Sector is 120 into, this will be 120 into pi into r square upon 360 minus, let us say this is r, half into r square into sine of 120 degrees. Now sine of 120 degrees, we have previously determined that sine of 120 degree is equivalent to sine of 90 plus 30 degree, which is equivalent to cos of 30 degrees, and this is equivalent to, or this is equal to root 3 upon 2. Cos 30 degree is root 3 upon 2. So this will become, this is 3 times, so I can take r square as common, to the bracket pi by 3 minus, it will be root 3 by 4. Now what is the radius? It is 12 centimeters. So my area will be 12 square to the bracket pi by 3 minus root 3 by 4. This will be the area of segment that is formed by this particular chord AB. Okay, so this is the solution for question number 15. Okay, so you can note this.